Inverter threshold voltage VTH, as was mentioned in chapter 1. The threshold voltage of the pseudo NMOS inverter is defined as the input voltage that gives an identical output voltage. Normally, for properly designed MOS inverter, this voltage would be approximately half the power supply voltage. To calculate this voltage, it is first necessary to determine the region in which a transistor is operating and which equations apply. Uh, that is the transistor in the triode region or the saturation region, which typically called the active region. First, it is safe to say that the enhancement n-channel drive transistor Q1 is definitely in the active or saturation region. This is true because for Vin is equals to V out, the gate drain voltage of Q1 is 0. Any enhancement transistor with VDG is equals 0 is in the active region. It will also be assumed that the P channel low transistor is also in the active region. This will be the case as long as gate threshold voltage happens to be less than 2.45 volts, which is almost certainly true for properly designed inverter. If this were not the case, then the devices would be would have been poorly chosen and the gate would be impractical, in which case it would not be described in this test. Under these assumptions, we may write the following equations for Q1. We have ID minus 2 equal to nu P C naught S by 2 W by L2 VDD by 2 plus VTP whole square, where it is assumed that VSG minus 2 equal VDD by 2. For Q1 we have VGS minus 1, Vn is equal to VTH, and RD minus 1 is equal to nu NC naught S by 2 WL1 VTH minus VTN whole square. Since it is always assumed that MOS gates drive only capacitive loads, we have ID minus 1 equal to ID minus 2, and we may equate equations and solve for VTH to obtain VTH equal to VTN plus root over nu PW by L2 by nu N root over nu PW by L2 by nu NW by L1 into VDD by 2 plus VTP. Thank you.